Hey guys, today we're going to learn about the complex plane. So we are in the past familiar with the rectangular plane, which is also called the Cartesian plane, and that's where you have your x-axis and your y-axis, and you use it to plot your points. Now the complex plane is used to plot complex numbers. So the x-axis that we're familiar with is going to become the real axis on the complex plane. So that's where we would put the real numbers. And then the y-axis is what we call the imaginary axis. So that's where we would plot the imaginary numbers. Now for complex numbers, if you have, for example, here, -2 plus 2i. -2 is a real number, so we would move on the x-axis 2 to the left because it is negative. And then plus the 2i means that we're going up the y-axis, which is the imaginary axis, 2. So this right here, this would represent -2 plus 2i. The same would go for all the other complex numbers. So for b, where we have 4 minus 4i, we would go to the right 4 because it's a positive real number 4. And then minus 4i means that I'm going to go down 4. So this would be the complex number 4 minus 4i. For c, 5 plus 3i, we would go 5 to the right and 3 up. So this would be that complex number 5 plus 3i. So knowing this, we can kind of work backwards, right? If you're given these complex numbers that are plotted, we can write out what they are. So for A, I see that from the origin, I would have had to have gone 1, 2, 3, 4 units to the right. So that is a positive 4. And then 1 unit down. So minus 1i, which we would just write as minus I. For B, we go 1, 2, 3, 4 units to the left. So -4. And then it goes down 2. So this would be minus 2i. For C, C does not go left or right, so this is a purely imaginary number since it is on the imaginary axis only. And since we go 3 up, this would represent 3i. Now, if you know how to get the complex numbers from the complex plane, then we could also apply these operations based on what these numbers represent. So what we're going to do first is we're going to label what each one of these letters represents. So for J, we had to have gone 1, 2, 3, 4 units to the left and 1 unit up. So that's -4 plus I. For K, I would move 1 to the right and 4 units up. So this is 1 plus 4i. L is 2 left and 2 down. So this is -2 minus 2i. M is 4 to the right and 1 up. So this is 4 plus I. And finally, N is 2 to the right and 4 down, so that's 2 minus 4i. So now that I've labeled all of my complex numbers, I can perform these operations. If I have J minus L, then we would do -4 plus I, because that's what J is equal to, minus L, which I'm going to put in parentheses because since I am subtracting the entire complex number, we want to make sure that we remember to distribute the negative. So anytime you have a minus, make sure that anything that goes after that minus, you put in parentheses. So now I would distribute this negative, and I would get -4 plus I plus 2 plus 2i. And now you would combine like terms. -4 plus 2 is -2, and then I plus 2i is plus 3i. Now let's change it up a little bit. I know it says k plus m, but let's say if I had written 2k plus m. Then that would mean that I would have to multiply k by 2. So we have this 2 on the outside. K is represented as 1 plus 4i, and then I'm going to add m, which is 4 plus I. So I would distribute the 2, which would give me 2 plus 8i plus 4 plus I. And once more, combine like terms. 2 plus 4 is 6, and 8i plus I is plus 9i. Lastly, for n minus k, I'm just going to add in here, let's do n minus 3k. So we have n, which is 2 minus 4i minus 3k. So I'm going to open a parentheses and write k, 1 plus 4i. And now when I work this out, I'm going to distribute this negative 3. So that would give me 2 minus 4i minus 3 minus 12i. And now we would combine like terms. 2 minus 3 is negative 1, and negative 4i minus 12i is negative 16i. So that's how we use the complex plane to perform operations, specifically adding and subtracting. Now let's look at one other thing for complex plane. We're going to now determine distance and midpoint between two complex numbers. So for distance, I put two different methods that we can use, and I'll go ahead and illustrate both, and you can use whichever one you prefer. Honestly, it does not matter. So I'm going to go ahead and plot these two complex numbers. We have 2 plus 3i, so this is represented as z, and w is negative 4 minus I. And so what I'm trying to calculate here is the distance. So I want to know how long this diagonal is. Now, I personally prefer using the Pythagorean theorem, and I'm going to show you how to use the Pythagorean theorem. Just as a reminder, we can only use the Pythagorean theorem if we are given a right triangle. Now, obviously, this line is not a right triangle, but I can create one. I can create a triangle whether I go this way or this way. It does not matter. So I'm going to draw my triangle like this. So basically, you're using the vertical distance between the two complex numbers and the horizontal distance between the two, so you can create the right triangle. Now, the Pythagorean theorem, A and B are represented by the leg lengths. It doesn't matter if you call this A or B or this A or B. So I'm just going to say this will be A and this is B, and the diagonal, which is the hypotenuse, is always C. So what I can do here is I can just, from my graph, I can just count the spaces to figure out how long A is. 1, 2, 3, 4, 5, 6. So A is equal to 6. B is 1, 2, 3, 4. So B equals 4. And what I'm trying to solve for here is C, because this would represent my distance. So the Pythagorean theorem, A squared, so 6 squared plus B squared is equal to C squared. 6 squared is 36 plus 4 squared, which is 16, is equal to C squared. 36 plus 16 is 52. And then to solve for C, I would square root both sides. So that means that C is equal to the square root of 52. But of course, whenever we have a radical, always simplify if you can. So let's see if we can simplify this. 52 is when you multiply 4 and 13. You could have also used 2 and 26. Remember, the pairing that you use does not matter as long as they multiply to give you that 52. 4, as we know, is 2 and 2. 13 does not have any pairs other than 1 and 13, so we would leave it. So I would write my final distance to be 2 square root of 13. Now to get the midpoint, and this is what we call the midpoint formula. What you do is you take the values of A, which is the real numbers, you add them together and divide by 2. Since the midpoint is the middle, what we have to do is eventually take those numbers and add them, divide by 2, and that gives you the average of the two numbers, which is the middle. For the imaginary part, we would take the b values, so just the numbers, and then divide by 2, and then we can't forget that we have the I. However, sometimes this can be confusing, so I'm just going to tell you more or less how you find the midpoint. So we're going to take, these are my two complex numbers. I take the real parts, so the 2 and the minus 4, and I add them together. So 2 plus negative 4 is the same as 2 minus 4, and then we divide by 2. And then we take the imaginary parts, 3i minus I, we add them together. 3i plus negative I is the same as 3i minus I, and then divide by 2. And now I put commas here just to indicate that I am doing the real part and then the imaginary part, but the midpoint is always a complex number. So we have to make sure that we rewrite this answer as a complex number. 2 minus 4 is negative 2. And negative 2 divided by 2 is negative 1. 3i minus I is 2i, and 2i divided by 2 is a positive I. So I would write plus I. And this would be my midpoint. And we can always use our midpoint and plot it to make sure that it does land in the middle of those 2 points. Negative 1 plus I means I would go to the left 1 and up 1. And we can see here that this is the same as this. So this is considered to be the midpoint. Let's try one more example. We are given here z is equal to negative 3 minus 4i. So I'm going to go ahead and plot that. Negative 3 minus 4i is down here. So this is z. And w is 2 minus I. So right here. And I want to find its distance as well as the midpoint. So I'm going to go ahead and create my triangle because I like to use the Pythagorean theorem. Oh, which by the way, I forgot to show you how the distance formula will come into play. So I'm just going to go back 1 second. So here is the distance formula for this complex number. And if I use the distance formula, a1 and a2, that would be the real numbers. So 2 minus negative 4. 2 minus negative 4 becomes 2 plus 4 squared plus 3 minus 1. We just take the number of the complex number. We don't actually take the I if we use the distance formula. So 3 minus 1, or rather 3 minus negative 1 becomes 3 plus 1 squared. And we get here that this is 6 squared plus 4 squared, which looks exactly like this. And then we end up square rooting it, which we do here. So using the distance formula and the Pythagorean theorem, they're essentially the exact same thing. So you use whichever method you prefer. Like I said, I prefer using the Pythagorean theorem because I'm a visual person. I'd like to see my triangle, and I also just like to be able to count those length spaces. So I'm going to use this every time, and you can as well. You would just need to have some graph paper or create a graph on your paper. So let's go ahead and calculate this distance. I'm going to call this A and this B, and I'm trying to solve for C. A is 1, 2, 3, 4, 5 spaces, and B is 3 spaces. So C squared, which is the hypotenuse squared, my distance, is equal to 5 squared plus 3 squared. 5 squared is 25 plus 3 squared, which is 9. So that means that C squared is equal to 34. And then I would square root both sides, and I get that C is equal to the square root of 34. Now, if we can simplify this, we would, but the square root of 34, two numbers that multiply to give me 34 are 17 and 2. And 17 and 2 are not pairs and cannot be broken down further. So that is my distance, the square root of 34. Now for the midpoint. Remember that for the midpoint, we take the real numbers and we add them. So -3 plus 2 divided by 2. And then we take the imaginary numbers, we add them. So -4i minus I, and divide by 2. -3 plus 2 is -1 over 2. Then -4i minus I is -5 over 2i. And this would be my midpoint. Again, if I would simplify, I would, but I can't. So we're going to leave it as the fraction. And if you wanted to make sure that you did indeed get the midpoint, we can always check. -1/2 is right here, right in between 0 and -1. And -5 over 2 is -2.5. So I'm going to go down 2.5, which is right here. And you can see that it lands right in the middle between my two complex numbers. So that's distance and midpoint. And for the rest of today's period, what you are to work on is IXL S7 and S8. And for both of them, you are going to get to a score of 80. If you finish before the end of the period, please make sure that you submit it on Google Classroom. And that's it. All right, guys, I will see you next week. Have a good one.